Welcome students. Today we will discuss relation between sinusoidal and complex exponential signals. To discuss between sinusoidal and complex exponential signals, we have Euler's identity or Euler's formula. Euler's identity says that e raised to the power j pi plus 1 equal to 0, where e is Euler's number, the base of natural law, j is an imaginary unit, identification of imaginary, that is j square is equal to minus 1, and pi is ratio of circumference to the diameter of any circle. Similarly, Euler's formula says that any complex exponential can be written in the form of real and imaginary parts. E raised to the power j phi is equal to cos phi plus j sin phi. We can see that if we put phi equal to pi here, we get Euler's identity, because sin pi is equal to 0, cos pi equal to minus 1, and minus 1 will be taken here, it becomes e raised to the power j pi plus 1 equal to 0. So both are essentially same identities, but named differently. Now, what is the role of Euler's formula? It is very important formula in communication system or in signal system all, because this formula relates the complex plane to the polar plane, or trigonometric identity to the exponential identities. It is a bridge between trigonometric and exponential identities, or how to plot a point in a complex plane in a Cartesian coordinate to the polar coordinate. Okay, so this is very important formula. Any complex number z is equal to x plus jy, where x is a real part, y is imaginary part, z is that complex number, can be represented by the point xy on the xy plane, on the complex plane, that is real and imaginary plane. Say this is the point xy. This point can also be represented in polar coordinates as r phi, that is radius and angle phi. It is the radius and angle phi. So this point can be represented in terms of polar coordinates as well as in terms of Cartesian coordinates, complex plane, x and y. Suppose this is x, this is y. We reach here x plus jy. So here x is equal to cos phi. So using Euler's identity, we can establish the relation that z is equal to r e raised to the power j phi is equal to r cos phi plus j r sin phi. Simply multiplying r both sides, we represent the z complex quantity in terms of polar coordinate as well as in terms of Cartesian coordinate. Now cos phi is equal to nothing but cos phi is what? From this, cos phi is real part of e raised to the power j phi, and sin phi is what? Imaginary part of e raised to the power j phi. Okay. So using this plane or planar graph, that we can see that both the planes are there. These are the Cartesian coordinate and this is the polar coordinate with r radius. Now you can find out that e raised to the power j phi is break into two parts, cos phi plus j sin phi. That's e raised to the j phi is the resultant value of these two values in real and imaginary axis, or x or y axis. Now similarly, e raised to the power on the circle we have different points, e raised to the power j phi, e raised to the power minus e raised to the power j phi, e raised to the power minus plus j phi, e raised to the minus j phi, and so on. On the basis of that orientation, all are 90-degree apart naturally. Now you can see that you can see simply these two have resultant value e raised to the power j phi. Similarly, these two have resultant value e raised to the power j sin phi. That is, this plus this divided by 2 is equal to j sin phi. It is written here, that is sin phi is equal to this e raised to the power j phi plus minus e raised to the power minus j phi by 2j. So this identity comes out from the resultant graph. Similarly, for the cos phi curve can be taken as this. Cos phi is nothing but the resultant between these two values, e raised to the power j phi plus e raised to the minus j phi divided by 2. So it is what cos phi. Further, we can elaborate the polar and Cartesian coordinate relationship by this formula, r raised to j phi equal to x plus j phi. Suppose x is that cos phi and y is what, sin phi here. For example, x is cos phi and y is sin phi. Then r, that is magnitude in polar coordinate, that is radius of that circle, is equal to under root x square plus y square, that is cos phi square plus y sin phi, that is sin phi square under root, and it becomes out to be 1 if these are to be taken. Okay, then this case, if x is equal to cos phi, y equal to sin phi, then r is equal to 1. And what will the angle? Angle phi is what? Tan inverse y is what? Tan inverse y. Y sin phi by cos phi. You can see that sin phi upon cos phi is 10. That is tan inverse is cancelled out with 10 and it remains only the phi. So this is the special case basically. This is the special case when x is equal to cos phi. Otherwise it is true in general for all over relation. So it is very important formula to remember everywhere in electronics or in communication system in different subjects. Okay. You must remember this relation. This is very important relation again, and this is again cos phi is sin phi. This is very important relation. And again, this is magnitude and angle is also relation. These three relations should be remembered throughout the study of communication system. Thank you very much.